Hey, this is Mohammed.
Hi, I'm Casey.
And I'm Stefan.
Okay, we start with this problem to figure out the free-body diagram and the kinetic diagram. We found three forces, which is the pulling force and the weight force and the friction force, and and here we find I through the radius of gyration, and we went then through the principle of impulse moment equations. We analyze it to x-axis and y-axis. So we understood that the initial moment for all the cases equals 0. Then we went to do the impulse equal the final moment.
After setting up our three initial equations, we use the diagrams to solve for the summation of the forces and the summation of the moment taken by point G. After that, we found out our variables, found our unknown variables. We plugged it back into our equations, and then we end up getting a Vx, a Vy, and then this had one unknown, which was delta. So we automatically got that from just solving, which was 44.44 radians per second. And then we took the magnitude of Vx and Vy squared and got V, which was 32.82 meters per second.
All right, to wrap up the video, I'm going to give a real-world idea of what exactly this problem looks like. So what I've done is I've set up a water bottle, just like this one right here, and it's got a larger radius here, a smaller radius at the head, and I've just set up this cable around the outside of it, and I'm going to pull the cable just like in the problem, and it'll show you exactly how it works.